Okay.
Perfect.
All right, are we ready?
Ready to go.
Okay.
Yeah.
So in order to reduce housing waste in the United States, there needs to be a shift in our relationship with our home. As your needs grow and change, we ask the question, why shouldn't your home change accordingly? We are the Green Electron team, and this is our presentation on Branch.
The aspect of the problem that we want to address is excess material waste. Houses get destroyed before the end of their useful life, and after they get destroyed, instead of reusing pieces of them, they get sent directly to the landfill, which adds to that 130 million tons of wasted material that then gets replaced with new construction. This problem arises because people grow out of their homes. In the US, 31 million people move annually, and that's almost 10% of the population. And although not all of those people move for that reason, it's a significant driver. We believe the problem stems from houses not being able to adapt to the changing needs of their owners.
And so our approach is to build a high quality reusable home modules. And so we want to be able to attach and reuse entire portions of the building. And so that'll include floors, walls, and roofs. We want to design for expansion, so you can easily add a prefabricated second floor. And we also want to be energy conscious and keep in mind ways to lower our carbon footprint and reduce our energy needs as part of the design. In essence, we want housing that grows with you.
So how are we going to achieve this? Well, here are 3 parts of the technical side of things. We've thought of a standard combination dovetail and rabbet joint that allows the wall to detach in entire pieces, which was inspired by the French company Brica Wood, as you can see in that diagram. We've also decided that the tongue and groove joint would allow us to detach the roof and add a second story.
We would also be implementing anchor bolts set in the concrete foundation to connect the flooring of the house, as well as radial bolts spread out over the roof ceiling connections to secure those tongue and groove joints, as well as standard bolts and sizes in predetermined locations in order to accommodate the ease of potential expansion.
And we want our home modules to be pre-plumbed wired and have the VRF line set in. In addition, we want to have a central raceway. In the event that you want to change some of the electrical connections, you just open a panel that's integrated and recessed into the wall. And so you eliminate a lot of the problems of changing and growing with your home.
So how do we put these technical components together to create our unique design? In the traditional stick-built home, if your family's needs change and you want to expand, you have to leave while there's invasive and time-intensive construction that goes on. You have to ultimately pull plumbing, electrical lines, VRF lines where they aren't intended to go. With our design, if you decide you want to add to your existing home, you might only need to be gone for the weekend. You order another story, employ a crane, and you come home to an all-new house. The roof itself is connected to the ceiling through those tongue and groove joints and fastened with radial roof bolts in strategic locations, as you can see in the diagram at the bottom of the screen. This makes the roof detachable and the home itself expandable. There'll be some finishing electrical, plumbing, and HVAC work that needs to be done to connect the 2 floors, but because we've created the central raceway to hold all of these components, that won't be as extensive as it typically is because everything comes with the unit. So all that you have to do is attach. And instead of knocking down walls to expand and add a bedroom, you can literally branch out.
And so just as we want to be conscious of a family's needs, we want to be conscious of the Earth's needs. And so we've built in energy efficiency and energy reduction measures. And these come in the form of heat recovery, VRF heat pumps, like we mentioned, the VRF lines, a corrugated metal roof, as well as basement cold storage. And these are ways that we can use the energy around us and not have to input energy and increase our carbon emissions as a result.
There needs to be a shift in public policy as well as in the mindsets of building companies and consumers. Public policy aiding in the cost differential between more sustainable buildings and the current new construction through subsidies will help to incentivize the switch to more sustainable living. Additionally, to further aid in the reduction of building material waste, the mindset of people to see potential in their current homes and economic incentive of building companies will need to transition to investing in more sustainable homes. We hope that you, construction companies, and homeowners alike will be able to branch out into a more sustainable future. Thank you for listening.
Thanks, guys.
Great, thanks so much. So now we can start our Q&A for 5 minutes.
Yeah, I guess I'll kick off. Nice job, guys. I'm curious what you guys see the end of life of your panels looking like, right? Like, so what happens? Like, we know that yes, someone may want to upgrade their home, but at some point it does need to be replaced, right? What does that look like?
And so this is something that Keely was talking about with the joints. Our idea is that pieces of the wall could actually slide out. So in the event that you actually do need to change a component at the end of life, you could disassemble these pieces in the same way you might think of Lego blocks and actually slide out that wall and switch it out.
Okay, so the same thing that's giving you the flexibility to add would also allow you to remove. Am I understanding that correctly?
Yes.
Exactly. Okay. So the deconstruction aspect of it is also made easier by the part of the design that makes it easier to expand. So it's sort of paradoxical, but yeah.
What do you think, Anton?
What about, yeah, kind of building off that, when it does reach like end of life, what about recyclability of these things? If you really need to get rid of it, if, I don't know, if something happens, maybe there's some moisture problem or something, you need to get rid of these materials. Did you guys consider recyclability?
Yeah, so I think Keely can touch on this a little bit with the wood specifically, but the reason why we were modeling after Brica wood was because it's actually wood with like an oil on top. And so the idea is like each component can actually be recycled as well. And so we went with the idea that we would choose these very high quality components because they can be recycled, but also because they'll hold up over time.
Yeah, but touching off of that, it's the way that Brica wood does it is it's sustainably sourced wood, and then they coat it in linseed oil, which allows it to sort of hold up against the elements. And then when it is at the end of its useful life, let's say you don't just want to take out one wall, you want to completely disassemble the house, all of that wood itself would be recyclable.
How easy are the panels themselves to be disassembled?
So the assembly itself, you sort of use the way that they do it with the Brica wood is what we're thinking, but on a much smaller scale. So they do it sort of individual bricks, and we're thinking of it as like panels. And they use like a rubber mallet to bounce it like into place because it's got this dovetail. Yeah, right there. Thanks, Skytree. It's got the dovetail and rabbet joint insert. So you put these side panels, the inner wall and the outer wall, onto those dovetail inserts. And so if you wanted to disassemble, you would just need to remove those, and then you would have them all in individual pieces. So I'm sure that after it's, you know, been there for a while, it's going to be a little bit like it's not just going to slide right out, but with the help of rubber mallets, the way that they install them, it should be pretty easy to remove.
Okay, maybe last question. If you guys had more time, what do you guys think you would have worked on or changed?
There's so much here.
We talked about so many things. I think one of the things we were really interested in was transportation of a system like this. We talked about how you would need to have some sort of line down the middle where you can have like each of these panels in C's, put them on their sides and inside of a truck. And then we ran into an issue with, well, we wanted 9-foot ceilings and the highway lanes are only 8.5. And so now you only can do 8-foot ceilings. And so we're sort of interested in how do people typically transport manufactured houses? Because I know that like that exists, total houses that are manufactured elsewhere and brought somewhere, but I think we would have looked more into the transportation side of things.
And I think also the calculation side of, okay, if you're actually going to be lifting these components off, now you have like your tub and you have your sink and everything attached. Is that feasible? And can the ceiling and the roof, can they support these components? Because right now we have the idea and we've looked into people who have done similar things. But I think for us to be really sure that this would work, we need to do our own calcs and simulations to really have that confidence.
To go off of what Gayatri was saying, also, I think wrapping our heads around kind of the cost of operation, but also to implement this from the building scale, just like all of the blocks, like finding a price for that. Although we weren't able to kind of run through all of those calculations, that would have been something we would have done if we had more time as well.
Sounds great. Thank you, guys.
Thank you so much. It was a lot of fun.
job. Thanks.
Thank you. Have a